Hi everyone. So this next section is an introduction to something called a proof. I don't know if you guys have any friends who took geometry before, but they probably told you, oh, proofs are the worst. They're really not that bad, so don't be afraid of them. We start off with the easiest type of proof just to kind of get used to what it is, and that's an algebraic proof. And so just to define like in general what a proof is, we say that it's a step-by-step explanation of how to solve a problem. There are all different types of proofs, but we solve the problem using mathematical properties. Basically, you do something and you justify it. You justify it either using a property, a definition, a theorem, a postulate. What we're going to do today, more specifically, is algebraic proofs, which what an algebraic proof is, you basically are just solving equations and justifying each step with a property. Don't mind that. Oh boy. My dog just knocked something over. She's fine. Okay. So let's talk about the properties that we're going to use. These first four, let's zoom in a little bit more. These first four are properties of equality that you pretty much use anytime you solve any equation. It's when you add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same number, or divide both sides by the same number. So anytime that you do that, it's these properties of equality that say that you can. So this just shows an example, like if I had A equals B and I added C to both sides. So it's these properties that say that when you do that, it doesn't change the equation. So this is when you add, subtract, multiply, divide both sides. It has to be both sides by same number. Reflexive property is something that we're not going to use quite yet. We're not going to use it in algebraic proofs, but we will use it in geometric proofs later on. And that's when just it says the same thing on both sides. Symmetric property we do sometimes use. Symmetric property, see it says if A equals B and B equals A. It's saying the same thing, but it's just flipped around. And there's a really loud airplane going by right now. Perfect. Transitive. So transitive property, again, is one that we're not really going to use in algebraic proofs, but we do use it a lot in other proofs. And so you may have heard of this property before. If A equals B and B equals C, then A and C are equal. So if you have two values that are equal to the same one, then they must be equal to each other, right? It'd be like if Bob and Jimmy have the same birthday, and then Tom and Jimmy have the same birthday, then Bob and Jimmy have the same birthday. That's always my example, is the birthday example. But if two values are equal to the same thing, then they're equal to each other. Substitution is used in a ton of different ways in proofs, but more specifically in algebraic proofs, substitution is when you basically combine like terms. So there's not really much room to write that over here, but we can just draw a little arrow. So anytime in an equation, if you are combining like terms, that's considered substitution, because what substitution is, it's like when you replace an expression or something for something else that it's equal to. It's like, I don't want to keep saying something, but it's kind of hard to explain it. It shows itself in many different forms. So as we do more and more proofs, I'll always like explain what substitution is. But for now, anytime you're combining like terms in an equation, it's substitution. And then distributive property, you guys all know distributive property when you have a number outside the parentheses and you multiply it through. That would be distributive. Okay, so the types of proofs that we do are called two-column proofs. So notice there's two columns separated by like a little T chart. The left side is what's called statements, and the right side is what's called reasons. The statements are the actual steps, and the reasons are the reasons, the properties, the definitions, like why are those steps true. Anytime you do a proof, there's always something called a given, and there's something called a proof. The given is the information that is given to you. So I know that seems kind of self-explanatory, but it is. So in a geometric proof, it might be like you might be given a figure and some information about the figure, and then you're asked to prove something about it. In an algebraic proof, the given is always the equation, and the proof is the answer. So we're going to prove that x equals 3 given this equation. So the number one rule with proofs is that you always restate the given for your step number one. So you always start with restating the given. No matter what kind of proof you do, that's what you do first. So that's always a real easy one. So you literally just rewrite the whole thing. And what you write for your reason, how do I know that this is true? Well, it was given to me. So you just write given. Next, since this is an algebraic proof, you literally just solve the equation, and every time you do something, you give a reason why that you could do that. So if we were going to solve this for x, also too, you want to number your statements and your reasons, and also try to like write them next to each other so it's easy to follow. So if I were going to multiply both sides by 2 here, I mean, that's what I would do to start this, right? We want to get rid of this too. So when you're doing it out in the proof, like you don't really have to show it. Like you could do this if you want to just show it up in this step, but this step would be the result of multiplying by 2. So it would be 3x plus 5 equals 14. So you really don't even have to show the 2 like that. And so for the reason you're asking yourself, like from this step to this step, what did I do? I multiply both sides by 2, right? So that's the multiplication property of equality. And so you have to write out the words. I do sometimes abbreviate property of equality with like this, property of equality, but you do need to write out the full, this part of it. Okay. Then think about what would we do next. If we were going to solve for x, we would subtract 5, right? So if I subtract 5 from both sides, I would end up with 3x equals 9. And again, if you want to show it kind of like small, you can, but you don't have to. I usually don't. So that would be subtraction property of equality because we subtracted the same thing from both sides. Okay. And then the last thing that we would do is we would divide by 3, right? So lastly, we would get x equals 3, and that would be division property of equality. And that's our first proof. Not bad. Notice that my last step matches my proof. You're never done until it matches exactly. Even if, like, if this proof said 3 equals x, I wouldn't be done. I'd have to flip it around. I think there's an example. Yes, there's an example where we'll have to do that next. So that's our first proof. We solved the equation. Every step of the way, we explained what we did. Okay, so there's number 1. Let's take a look at number 2. So again, we have a given and a proof. So I'm going to restate the given. Okay, so the first thing that we would do here to solve this is we would do the distributive property, right? We're going to distribute this 2. So this is going to be 30 equals 6x plus 2x minus 2. And that would just be the distributive property. Okay, next thing we would do is combine these like terms, right? 6x and 2x would be 8x, so 30 equals 8x minus 2. A very common error that kids make here is because, yes, we did add them, kids want to say addition property of equality. It's not addition because we didn't add anything to both sides of the equation. I'm simply substituting and replacing 6x plus 2x with 8x. So I'm substituting this with this because they're equivalent, right? 6x plus 2x is the same thing as 8x. So I'm substituting it. So that's called substitution property of equality. That's the one that I said comes in many different forms. But in a proof, it's when in an algebraic proof, it's when you combine like terms. Okay, next thing we would do is add 2 to both sides, right? So this is going to be 32 equals 8x and we added 2 to both sides. So this is when it would be addition property of equality. Lastly, we would divide. Well, actually, not lastly. Whoops. So if I divide by 8, I'm going to get 4 equals x. Notice that everything's numbered and everything's like in line. I don't have like statements down to here and then like reasons really small. Everything's lined up. So you want to keep it really organized. So to get that, I divided, right? So that's the division property of equality. Now here's what I was talking about. See how my last step says 4 equals x? But look at my proof. My proof says x equals 4. Those do not match exactly, so I'm not done. So I have to flip it around and write x equals 4. And that's actually property. So remember back in this chart, the symmetric property of equality. If A equals B, then B equals A. It's just flipped around. That's what this would be. So if you ever have to flip your last step, that's the symmetric property of equality. Okay, so there's our second one. And let's do the last one. So given 2x minus 7 equals 1/3 x minus 2. That's given, so we always start with that. Okay, I'm going to show you guys kind of a different way that you could do proofs if you wanted to. So if you were going to solve this equation, some people might multiply everything by 3 to get rid of the fraction. I don't know if you guys have ever seen that before, but that's like a strategy that some people use to solve equations. Some teachers actually like teach it that way. I usually just like let you decide whatever you want to do. But I just want to show you for the sake of how distributive property can look and how multiplication can look. So if I were to multiply everything by 3 here, if you wanted to show it, you know how I keep saying like you don't have to show it out that what you're doing, like you can. So say I wanted to multiply everything by 3 to get rid of that fraction. Whoops, I forgot to put the 3, that's okay. Like you can actually show it like this, and that would still be multiplication. And then when you simplify it, since we have a number outside the parentheses that we're like distributing through, that would be distributive. So this would be 6x minus 21. And then 1/3 x times 3 would be x. And then -2 times 3 is -6. So you certainly didn't have to do that. You could have just solved it normally, but then just worked with the fraction. That's fine. You could have also, oh, you know what? I was going to say you could have also gone straight from here to here, but you actually couldn't have done that here because there was nothing to distribute here. So you had to show that you wanted to distribute something, that you wanted to multiply everything by 3 and then actually distribute it. So never mind. The example that I was going to show you kind of backfired. But this would still work. So you could show that you want to multiply everything by 3 and then actually distribute it through. And again, this is not the only way to solve this equation. You could just have solved it normally. I just wanted to show you another option. Okay, so from here we have 6x minus 21 equals x minus 6. We have to bring the variables on the same side and bring the constants on the same side. So I'm going to bring x over to this side, so it's going to be 5x minus 21 equals -6. Also, too, you want to always do one thing at a time. So I couldn't bring the x over and bring the 21 over in one step. Like that's personally like what I would typically do when I'm solving an equation like this. I would have done it all at one. But because you have to give a reason for each one, you can't do that. So I subtracted x from both sides. So this is subtraction property of equality. It's my dog digging on the rug. Don't mind that noise. All right, next I'm going to add 21 to both sides. So I'm going to get 5x equals 15. It's addition property of equality. And then lastly, I'm going to divide. So that's x equals 3. And that's it. Notice it matches exactly. I have x equals 3, x equals 3. I don't have to flip it around or anything. So I'm done. And so that's algebraic proofs. They're pretty easy. If you have any questions, you can come by. I'm using the ACT Lab link today. So you can come during your like normal class period, or really at any time. I just may be working with other kids if you come in a time that's like not your class period. So yeah, so that's it. We will probably just go on to geometric proofs next time. Maybe we'll do a couple more of these, but most likely we'll just go on to geometric proofs. All right, that's that. Hope that this was easy, and let me know if you have any questions. All right, have a great day.